So this entry ticket is going to continue looking at transformations. In particular, we're going to talk about exponential functions today. Those are functions where the x is in the exponent. In this case, we're asked how does f of x equals 2 times a base of 2 raised to the negative x plus 4 minus 5 transform the function f of x equals 2 to the x. And to do so, I think looking at decimals is super helpful. Looking at the entire function, probably a little bit confusing, but if I look at just first off, what does 2 to the x normally do? As you can see there, as the x increases by 1, the y is timesing by 2. So a 0 gave us a 1, and then we do slide over. 1 times 2 is 2, 2 times 2 is 4, and 4 times 2 is 8. So an exponential function is repeated multiplication by the same number. In this case, it is 2. Now, looking at the individual parts, if I look at just the function, what does that 2 in front do? Well, that's our a, and what you should quickly see, it doubles everything. It is a vertical stretch with a factor of times 2. It made everything twice as tall, twice as fast. Okay? So now, what does the negative in front of the x do? Well, on its own, you should see kind of immediately it appears to be a reflection horizontally across the y-axis, and indeed an x of 1 gives us 2. The mirror, the opposite of x positive 1 is negative 1. That gives us the same value. Same thing if we go around, negative 2 is a 4, just like before. 2 was a positive 4, so that is a horizontal reflection over the y-axis for the negative. How does the plus 4 transform the function? The plus 4 inside the parentheses and part of the exponent. So looking at just the plus 4, what you should notice is we have shifted the graph. If I take out the minus 5 real quick, the graph has shifted over. I put a negative 4 in. The thing that was happening at x equals 1, give me a second, there we go. My bad. The thing that was happening, actually, this is a good example. Okay, I can look at it two ways. If I go to x equals 0 slash the y-axis, right there, a 0, 1 is now a negative 4, 1. So we moved left 4 units, okay? The other way I could look at it, a 1 minus 4 would give us a negative 3 for our x value. So the point 1, 2 is now negative 3, 2. It moved over 1, 2, 3, 4 units. So on its own, the 4 in the parentheses, the h is moved it left 4. What about the negative 5? Well, again, looking at it, let's just add it onto the function right now. So I got that red function. I put a minus 5 on it. Well, it moved down. If I look at values here, it moved the function down 5. Let's take the plus 4 out so that way we really illustrate that. Right there, it is clearly down 5. If I look at a little nicer value, right there, at 1, we had a 2. Now at a 1, we have a negative 3. So the minus 5 moved it down 5. And that's what k has been doing. Now, the thing that is a little bit tricky is that the entire function, because it flips, it appears, now it's shifted 4 to the left, but because of the reflection, it looks like it went 4 to the right. That did not actually happen. The reflection caused 4 to the left to turn into 4 to the right, okay? And then lastly, looking at a couple values. So if I'm asked, what's the value at a certain number on a function? All I got to do in Desmos is type in what those are. So x equals 1, x equals 2, and x equals 4, okay? So at a 1, we get 11 on the dashed function. At a 2, we get a 3, and at a 4, we get a negative 3. So when I go to Desmos, I know I need to hit those points. Most Khan Academy windows, I need to hit that 0.23 and that 0.4 -3. And most of the Khan Academy problems are going to be a little bit simpler and not have quite so much going on. Ultimately, I use those three values because they're perfect intersections of X and Y. Please use this to give the Khan Academy practices your best effort and have them done by tomorrow.